Welcome back to Daily LeetCode. It is day 112. We are alive, and it's another day, another dollop of misery. But maybe that's epic. Maybe the idea that we get to experience misery for another day is a gift. Maybe it's not a gift. We have some comments today. And we have a yellow arm bicep emoji from Tran Minhan with a cool profile picture. Respect. Feeling that. Respect. When bro finally solved that, it was the most satisfying thing on day 109. True. I know exactly what they're talking about. It's the NIM game. That problem was pretty cool. That was one of the problems where you'll do, or one of those marker points where you'll do something and you'll be like, wow, I can physically feel you could physically feel the difference in your mental capacity to do something. Where I was like, 112 days ago, there's no way I would ever figure that out. That was one of those problems where it was like, we made progress. It's always amazing to feel that. When bro comments, it is the most satisfying thing. When you comment, it is the most satisfying thing. Feels strong, man. Epic moment, man. I would have a question or a comment from Niall. I answered this question yesterday, but I wrote it in text so as to be just wanted to give it the space, space for the question to breathe. And I didn't have much time yesterday, but we have a few extra minutes today, so we can jump into that account. I appreciate the fact you don't try to get the most. When it comes to anything I've done in the past, all that mattered was the hours put in. When I got a PC for the first time, I was trash at writing. Now I can write at 70 words per minute, which isn't impressive per se. The point is that I didn't have to go out of my way to get better at it. It just came naturally since I put in the hours. Now with coding, I'm at a crossroads. I have the time, will, and motivation to put in 10-hour days. I'm just not sure if it's the optimal way. Read several studies saying that the most human beings can truly focus for 6 hours or so. The way I took the studies is like anything from 1 to 6 hours, and you get linear growth and benefits. Anything over 6 hours, you'll still get benefits, but perhaps just diminishing ones. To put it short, if you had 10 hours of free time daily, would you study for 10 hours, just study for 6 hours, focus super hard during those 6 hours? Whoa, that's pretty deep. That's really awesome. Yeah, that's really interesting. Yeah, the fact that now can put in 10-hour days, I think, is incredible. That's like a goal. Like if I could do that, I think I respectfully think the closest thing I could get to is maybe 4 to 6. But 10, I don't know if I could ever get to 10. Maybe in a couple years, I think I could get to 10. That would be awesome though. But put sure if you had 10 hours of free time daily, would you study for 10 hours, just study for 6 hours and focus super hard? Well, this is interesting, right? So the studies that say the study we're saying human beings can truly focus for 6 hours or so. It'd be interesting to know if that is straight through or broken up, because I think in another comment it was mentioned that he was or they were breaking them up in the sessions of 2 hours. So I'd be curious to know if it's all in one sitting, right? If the max one can focus for a 6 hours straight or not. But it'd be interesting to think about. I think on the Huberman Lab podcast, Andrew Huberman mentions that I think in some of the learning-based studies, the max learning, block is like 1 hour and 30 minutes. And that it might be best to do those blocks split up. But I think it also goes on to, I think another thing to think about is that it also goes to question, what does learning mean? I mean, like you said, you have the linear growth and benefits, right? What does it actually mean? So if you put in 6 hours, at what point how do you say this? It's pretty much like, for example, if I do LeetCode for 6 hours, I don't really learn anything. And I think for hour and a half, it's perfect. And if I go on later, it's actually even better by breaking long sessions up into multiple sessions split with a little bit of cooldown. but I think it makes one question, what is learning? For example, I think you could learn for 6 hours if it was broken up, like maybe 1 to 2 hours of reading, writing, maybe putting things down, maybe for spaced repetition, maybe another hour and a half of doing spaced repetition, and then maybe 2 to 3 hours of application. But another way to simplify the whole thing would just be to do maybe some sort of learning that combines application with ingestion of information. Because I think one aspect, I don't know this stuff very well. I just kind of trying to figure out something that works. But I ran into a similar issue where I didn't have 10 hours of time, but I had felt like I could do like 2 to 3 hours, and I ran into the issue of like, okay, how could you make this most optimal? And yeah, I think at first it was mostly ingestion of information, like reading this and reading that. Then I found that to be a little bit shallow because the information doesn't really have anywhere to hang in the tree, and if the tree shakes a little bit, then the information falls out. So, and then I started to mix it with application. Application is like a really good encoder for knowledge. I don't know why that is, but it just seems to do it. And I think a lot of people seem to, I think it seems to be like a lot of humans feel, or a lot of people usually lament or say that they have, it's easier for them to learn by doing. So maybe that has something to do with that. But would I study for 10 hours? I would probably break it up into a circuit. So if I did have 10 hours of free time daily, I would probably open the day with a 1 hour workout, maybe like 15 minutes of cardio or 20 minutes of cardio, 30 minutes of cardio, maybe 40 minutes of lifting. Then I would do maybe an hour of LeetCode. Then I think I would probably take a break, maybe a 30-minute break, and then I would do a 1.5 hour to 2 hour block of personal projects, and then I would do a break, and then I would do another 2 hours of another long-term goal. So something else that I want to be able to do long-term, right? And that way I think I could cross off at least a bit of a goal in every aspect. So if I had more time, I would add more categories. So the LeetCode and the working out is just integral to the whole process because LeetCode helps me focus, and the working out is just good for health. And the next thing I would go for is the personal projects because those are things I kind of want to put into existence. But then I also have some like story-based interests, like maybe, like just artistic-based interests, like being able to animate or something like that. And I'd like to put some time into those things, but in the current schedule, there's just no space for those things. And then that would be, I think, 6 hours, and then there'd be another 4 hours. And I'd probably do another 2 hours of personal projects, actually. Yeah, and then I'd probably do another 2 hours of the artistic interests. But yeah, I guess, it's hard to say. It really depends on the goal. I guess if it's just to optimally learn as much as one can, yeah, I think the best way might just be breaking it up, or mixing. If we're talking about optimality, maybe mixing an application as well. One really good website for this, I think, is Codecademy. And the issue is that with a lot of online learning courses, it's just really hard to find a course that actually blends like ingestion of knowledge. Like, okay, I'm going to explain to you a concept like as if you're reading it in a book, and then we're going to apply it together. And then in the third phase, I'm now going to give you a general like scoped task, and you're now going to use the information both from the ingestion and the application to do it, which is a lot like how you would learn to do something if you were like at a job or something. And I think Codecademy's way of doing it is just like, I think it's just incredible. So a lot of the courses that I take are from Codecademy because it's like the only place where I actually learn something. Or it might just be me though, since I think places like Udemy, Coursera, like they're very like video based, and I don't seem to really learn anything from those videos. It's like I'll watch the video and I see what they're doing, but then if I had to do it myself, I couldn't do it, or I couldn't really explain exactly why. But yeah, I would say yeah, Codecademy is something that mimics. You don't have to do Codecademy, but something that mimics Codecademy's formula, where it's just like a little bit of ingestion, a little bit of hand holding, and then now you have to do what they were saying, but without any help. And then you have to, it like forces you to recall it, and then that struggle, that struggle of recollection usually solidifies the memory, is what they say happens in our brains. But I found that to be kind of tangentially true. But yeah, I'd be curious to see. Yeah, I'm at a crossroads as well. So so I think we are in the same boat. I think we're in the same boat because I feel the same. I have time to do these things, but yeah, I'm just trying to optimize as much as possible so I can, you want to get where you're going. So yeah, I feel that very, very much. So I all the stuff I was just saying is just stuff I've experimented with. And yeah, the video courses don't really work for me. The reading only aspect didn't really work because then there was no application. One example, I read an entire system design book called System Design Interview by Alex Zhu. I ingested some concepts from there, but if I had to build a system today, it just wouldn't be good. And yeah, so I think stuff that kind of, this is the whole thing. So I feel like I should have had more time, but I personally think that application is the best encoder for knowledge, whereas I think oftentimes things are structured the opposite way. So you learn something and then you try and apply it, which can be helpful. But what if you could apply it in the beginning, right, to encode the knowledge? And that's why I used to use a space repetition tool that I built for LeetCode, because I found that to be the best way to learn something. So I would do a problem, and let's just say something like a complex concept, like not really that complex, but something like Hamming weight, where you have to, count the number of bits in a number. There's like a couple of different ways to do it, and there's also another way which is really uses a lot of bit tricks and stuff like that. And there's a solution there where you can read it, but you never really remember how to do it. And so the space repetition tool, instead of forcing you to remember a rote fact, it would force you to space your practice. And so you would redo the same problem over and over again, but spaced. And what that goal was to basically just use the application or the process of solving the problem, even though you solved it already, to encode knowledge. And that is what helps me a lot. I don't do it anymore just because that thing is a whole thing in and of itself, and there's like an issue with like exposure, I think, because I think there was a lot of tuning that needs to be done with testing, and it just kind of got out of hand. And also I had too many problems in. And the other thing that's always a problem with space repetition in general is knowing what deserves to be recalled. And that's like the greatest bane of space repetition use, is knowing what's worth recalling. So yeah, that's a long way of saying I'm also still figuring this out. So I'd be curious to see how you struggle it. How you structure it as well. So that would be really interesting. But I would be curious to know. But we're a bit short on time today because I talked for too long. I need to stop talking. I can't believe we talked for 14 minutes, but we're gonna aim for 55 minutes today, since I spent a little too much time talking. And then we're gonna go for power of 4, reverse vowels of a string, moving average, logger rate limiter, closest binary search value. And yeah, so we're just going to jump into it. I'm going to say, given an integer n, return true if it is a power of 4. Otherwise, return false. An integer n is a power of 4 if there exists an integer x such that n is equal to 4 to the x. N equals 16, output is true. N equals 5. It's not a power of 4, n equals 1 is a power of 4. Could you solve it without loops or recursion? We can definitely do this in log n time. But there's a loops without recursion version. There's like a specific number you can do modulus by. And it should give you the right answer. But I don't remember what that is. I think maybe there was another problem that was similar. But I think what we can do, since we're just being asked to search, for an integer x such that 4 to the x equals n, I think we can rephrase this answer as, given the range of numbers 1 to 2 to the 31 minus 1, what number, if any, exists, will, when not multiplied but squared by x, will give you n. If that's the case, then our search space, our solution space, is just 1 to 2 to the 31, and so we what we could do, since that's the case, what we could do is just do a linear search over 1 to 2 to the 31, which would give us a worst case of 2 to the 31 operations. It's just in saying just in case we had to go to the end. We would never have to go to the end, but we'd probably have to go to somewhere near the end. So maybe somewhere like 2 to the 31 divided by 4 or something like that. But if that's the case, if it's just a linear search over a search space that is all whole numbers, we can just, instead of doing a linear search, we can do a binary search. Then we could bring this to log of n. We could bring it to log of n with a binary search. So I'd say I think that's what we could do here. And I don't know how to do the follow-up where it says no loops or recursion, but we'll try it anyway. And with the binary search, we typically have a range that starts with the maximum or the entirety of all the numbers. Then we split or partition based on where we currently are. So basically we have a pivot, and that pivot we calculate it to be at a certain point. Now if our pivot is not meeting the requirements, then we'll just select the range based off the pivot, and then we slowly slice and dice. Hopefully we should cut the search space in half or the solution space in half on each iteration, which should give us log of n time. And the other thing that's important for a binary search is that our numbers are already sorted, and because we're searching in this space right here, they are already sorted. So to do that, we'll just say that left starts at 1 and right starts at n. So while left is less than or equal to right, we're going to calculate our pivot, which is going to be left plus right minus left right minus left over 2 dot floor, and then we'll say if pivot, or if 4 right to the pivot equals n, and we have to know, right, the pivot that we're calculating here is actually going to be our exponent, right, which is x. That's why we're going to say 4 to the pivot equals n. Then we can return true, it is a power of 4, right? Else if 4 the pivot is greater than n, right? Let's just say our range is 1 to 100. We calculate a pivot, right? And let's say our number is 16 or something. Oh no, let's just say it's 32. And if I do 5 to the 4th, or let's just say I do like 10 to the 4th or 4 to the 10th, right? That number is clearly greater than 32. So if 4 to the 10 is greater than 32, right? So we can imagine it like this. 4 to the 10 is here and 32 is here. if 4 to the 10 is already bigger than the number we're searching for, then there's no point searching 4 to the 11th, 4 to the 12th, 4 to the 13th, 4 to the 14th. So we might as well skip those things. And the way we'll do that is by modifying the left and right boundaries. So we would now say that right would be equal to pivot minus 1, I believe. So 4 pivot is greater than n. We'll set right equal to pivot minus 1, which is perfect, right? Because right used to be the whole range. Right now it's going to be where pivot is minus 1. So it's a smaller range. And we can do 4 to the pivot is less than n. We'll do left is equal to pivot plus 1 for the same reason, right? If we calculate a pivot and it's smaller, right, than the number we're looking for, that means everything before it is also too small. So now you just want to move left up to pivot plus 1. So if it was like this, now it becomes like this. And I'm curious if you can just return false, but I think we'd have to follow it through. So let's start with n equals 5, right? Left would be equal to 1, right would be equal to 5. 1 is less than 5. 1 plus 5 minus 1, which is 4 over 2 is 2, which gives us a pivot of 3. 4 to the 3 gives you 16, which is not equal to n, which is 5. Then we have 4 to the 3, which is 6. 16 is greater than n, so we're going to say right is going to be equal to pivot minus 1. So now left is 1 and right is equal to 2. Right is equal to 2. 1 is less than 2. We go 1 plus 2 minus 1 is 1 over 2 is 0.5, which is 0. So now we're at 1. 4 to the 1 is equal to 4, which is not 5. 4 to the 1 is still 4, which is not greater than 5. And then 4 is less than 5. So we do left equals pivot plus 1. Now left is equal to 2. And then, yeah, I think we should be able to return false. But I think we're going to want left actually to start at 0 so that we can get numbers like n equals 1. So let's try the other test cases. I don't know where the test case button is because they moved the stuff, but I guess now you can just click them to try them. It's already, it passes all 3, I guess is what they're saying. So this one runs in 554 milliseconds, which is not very good. I mean, it's log n though, so, or it should be log n. I'll try it with something like, yeah, it should be pretty quick. So yeah, I think that's the fastest way I know how to do this. The version with no loops or recursion, I have no idea how you would do that. I see. That's interesting. If the max number is 2 to the 31 minus 1, then the highest you can do is 4 to the 15. So they just check if the number... They just calculate all... They just calculate all the powers and check if the number that they want to know is a power 4 or does it already exist in the list of numbers. Interesting. That is very clever. Given a string S, reverse only all the vowels in the string. Given a string S, reverse only all the vowels in the string and return it. Given a string S, reverse only all the vowels in the string and return it. Vowels are A, E, I, O, U, A, E, I, O, and U, and they can appear in both lower and upper cases more than once. So A, E, I, O, and U. In LeetCode, there's only E and O. And so E and E, and then E and O, and then that's it, I think. So I think we can solve this. I guess we'll do this one in TypeScript. I guess the way I would go about doing it, we can just augment string reversal function left and right must equal vowels, lower or upper. So we're just going to do the string reversal method, except we're only going to swap the strings. Only going to swap characters if they're both vowels, or swap indices when they're both vowels, and then we'll stop. So we can try it first here on this example right here. And I should make this bigger. I don't see why it's always so small. And then I'll return an empty string just to see if the console still pops up. Looks like it does. So let's see, right? We'd start with H and O, right? So we start at one pointer, which would be far left, and one which would be far right. Then we'll ensure that both are pointing at vowels. Left is not pointing at a vowel, so we'll increment until we find one, which is E. And then O is already at one, so then we'll swap them. Now we're going to go to the next iteration, increment both, increment left and decrement right, and then ensure that they're both pointing at vowels, and move left until it finds one. Right, we have to move left, right until we find one. Now they're both at E and O again, which means they passed each other, which means we're done. So I think the other thing we're going to need to know is know if var is vowel, and the other thing is modifiable string. So I think we can check a couple of these off by just saying, by turning the string into an array, we'll just split it by empty string. And then from here we'll have an array that we can modify. And then we're going to need a left index, which is going to start at 0, and a right index, which is going to start at the last element in the array minus 1. We'll say while left is less than right. We're going to return the array joined. Here we'll ensure left is vowel, ensure right is vowel. So we'll have an inner while loop, which is going to say while left is less than right, and r sub left is not a vowel, and so the way we'll know if something is a vowel is we'll say vowels, and it'll be a new set, and I think you can just pass in an iterable, and this set will have a E O, capital O, and capital U. So now I have the vowel set, and we'll say n vowels dot has. Oh, and vowels does not have the current character, right? It wouldn't have the character, right, if it wasn't a vowel. And if that's the case, if it's not a vowel, then we want to keep incrementing left until it is a vowel. We can duplicate this for here, except change our process to be minus equals 1 and change this value in here to be right. And now we're sure that they're both vowels. And so we could swap them here. But just to be certain, yeah, actually they should both be vowels because they'll stop once they reach one, unless there's no vowels. So they'd be at the end of the string. So we just have to make certain that they don't swap the last characters in the string when the string has no vowels. So we'll still have to do vowels dot has r sub left and vowels dot has r sub right. Then we're going to say we'll swap. So we'll say onStemp equals r sub left, and then we're going to replace r sub left with r sub right, and then r sub right is going to get the value of temp. And then we need to actually increment the indices as well. So I know I shouldn't run this to start, but I really want to know if it would just work. Does it work for the second case? Feels strong, man. So yeah, that's pretty cool actually. That is pretty cool. So yeah, it looks like a variation of another problem. So that is pretty cool. And I think this should run in linear time. Linear time. And I think if we consider the output as part of the space, it'd be linear space as well, since we have to cast the string to an array, or convert the string to an array that is reusable, or modify or mutable. That would be linear time, in linear space as well, I guess. That is pretty cool. That's another one that is satisfying to solve. I'm curious if there's a faster way to do it. I don't think so. The worst case here is, I will see actually. This is actually exactly what we got. average. So we'll try moving average next. This is a premium problem. Given a stream of integers and a window size, given a stream of integers and a window size, calculate the moving average of all integers. Given a stream of integers and a window size, calculate the moving average of all integers in the sliding window. Implement the moving average class. Given a stream of integers and a window size, calculate the moving average of all integers in the sliding window. Initialize the object with the size of the window size. Double next returns moving average of the last size values of the string. What do they mean by that? So you have moving average, next, and next. We have 3, 1, 10, 3, and 5. Explanation, moving average, do moving average 3. So the size of the window is 3. Moving average dot next. One, okay. I think there's a brute force where you could just linearly calculate the last n numbers. And the screen, the text is massive on this screen. But I think there's a brute force method where you can just, you have size, you want to calculate the last 5 values of the string. So you just calculate them from the start. But I think you could also just save the ranges in a hash. Or you could pre-compute all the values. So in initialize, well, we don't know actually. Actually, we could. Wait, when are the values? Integers and window size. Wait, now I'm confused. It says returns the moving average of the last size values of the stream. Oh. think I was thinking too complicate. It's just every time you do something, you add a number. Then you take the range. Looks like we have at size equals size. We have a sum which equals 0, and I'm just thinking we can just I'm thinking we can just have this array of numbers and just add them to the end. Oh, I think that's the problem with the array. So we definitely shouldn't use an array. Then we can just use sum. So we'll use sum and total nums, which is 0. And then there'll be two cases, I think. One case where we don't have enough, we don't have enough elements to satisfy the size requirement. And if that's the case, we'll just return the division of the sum so far. So the sum so far. And we can also have something like last num, which is equal to 0. So we'll do it like this. We'll keep a window of the sum of numbers, right? And whenever we go next, we'll say last num Yeah, I think it's actually better to do this with an array. That way we can remove the last number. It mostly just will be to keep track of the last number. So I think I could write this and start figuring it out, but I want to think it out before I write it so that it just makes sense. We have an array. We have a window of, let's just say, 3 elements. I'm going to say next and add 4. If that's the case, sum, we would first, you have the sum. We would subtract last number, add the new value, and then divide it. We only want to do that step though if we're greater than, if size is equal. Okay, so I think we'll have a case where if we'll have a case where if nums.length equals at size, then we'll do window length shifting. Otherwise, what we'd like to do, we just want to add sum plus equal val. We'll say at nums dot push val. Sum plus equal val at nums dot push val. So we'll push the value onto the numbers at the end. Then we want to return the running average. And then I think we would just return at sum divided by, and we'll say divisor, right? If at nums dot length equals at size, all right, then the divisor should be size. Otherwise, it should be at nums dot length. And when the nums dot length does equal the size, then what we're going to want to do is do at sum minus equal at nums dot shift. So we'll subtract the number from the front of the array. And now I'm realizing we actually don't want this in an else. We'll just keep this out here. And we can just write this in Ruby mode if we just do it like this. So so is this a Ruby issue? We're missing decimal values. Maybe I should do sum equals 0.0. Okay, it looks like that is the case. That's a lot of memory, but I think Ruby just tends to be like that. But still, even the Ruby leaderboards not doing very good. Is there a way to do this better? I don't think it's possible. Well, maybe it's not. You're receiving the numbers. You're receiving the numbers dynamically. You're receiving the numbers dynamically. Since you're receiving the numbers dynamically, could you do it with less space? But how would you know what number to remove? I mean, next worst case time complexity is linear time. In fact, if next was called a lot, it would probably be closer to. It would probably be closer to n squared, just because shift takes linear time. For taking an element off the front, we have to shift all the elements down one. But if we had a deck, then this would be constant time, I think, or a linked list, because we could remove from the front constant time. So maybe next is constant time if we have the right data structure. Yeah, and we need n is the size of the moving window. Circular queue is pretty cool. They just use the queue. We do add one. Right, tail is equal to self.head plus 1. Now it's self size. That's pretty cool. That's really cool. So we have logger rate limiter. Design a logger system. Design a logger system that receives a stream. Let's do closest binary search tree instead. Given the root of a binary search tree and the target value, given the root of a binary search tree, given the root of a binary search tree, which is 4, and the target value, return the value in the BST that is closest to the target. Return the value. Wait, didn't we just do this one? Yeah, we did this. And I think we just did in order traversal. Value in the BST that's closest to the target. So again, the target is 3.71. Yeah, I think we just I feel like we just got the BST as an array by doing in order traversal. I remember now. And then we took the absolute value of the difference, and then we sorted it by that, and then we returned that. Let's see what other problems remain. I don't feel like doing logger rate limiter. Let's try valid perfect square, guess number higher or lower, find the difference, is subsequence, binary watch. Given a positive integer num, given a positive integer num, write a function which returns true if num is a perfect square, else false. This is kind of like the power of 4 problem we just did, except we're only doing valid perfect square. Do not use any built-in library functions such as square root. 16 is 1. 14. So I think we could do the same thing, except I think we're going to go 0, 0, 1, 1. 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. And then our range there. So we're going to do the binary search again. Or we could also do what they did last time, do it in constant time. If we check what the highest you can go with perfect squares is, and if we check 2 to the 31, gives you 2 billion and 100 and yeah, it gives you 2 billion basically. So if I do 10 to the 10, 14 to the 14, oh no, if I do, wait, 10 to the 10th power gives you 10 billion. So I think we could just calculate this. I love yeah, I ain't gonna lie, LeetCode went crazy. I'm really liking the type, or what do they call it, the auto completion or the type annotation. I forgot what they call it, but if perfect has num. So it definitely should be in there. We have a set. I equals 0. I goes to 10. And we add I to the I. Oh no, wait, 4 to the 4. Oh no. Perfect squares are, wait, I thought perfect square was it by itself, or it against itself, so 4 to the 4. But I think it's squared. Oh right, it's why they call it perfect square. Oh man. But that means I think we have to go higher than 10 now. So let me check. Let me see how high you can go. Is this still fire? Now we just do 100,000 operations every single time. I think I'm just gonna do the binary search version. Yeah, I thought, yeah, this one is definitely not a case where maybe there's an easier way to pre-compute all the values, or maybe there's another way, but I think the binary search will be fine. So we're just going to, our base number is pretty much going to stay in the previous binary search, our pivot was the exponent, which was changing. Now our number, it's going to be changing. It's just the actual number. So we'll say let left equals 0. We're going to let right equal num. We'll say while left is less than or equal to right. And we're going to calculate our pivot, which is going to be left plus the math right minus left over 2. And we'll say we'll just say constant value is going to be equal to pivot, which is the actual number, to the second power if value equals num will return true, and then else if value if value is greater than num, we're going to say that right is equal we're going to say right is equal to value or pivot minus 1. And if value is less than num, we're going to do left equals pivot plus 1. And then down here we'll return false. Interesting. So I think this would be log of n, and they don't ask for a follow-up that is like some kind of constant time or space or without loops or recursion. So I wonder if there's a better way. So that's what we did, the binary search version, which is log of n. Newton's method. Yeah, all right, the math is crazy. Newton's method, that man was a genius. We are playing the guess game. The game is as follows. I pick a number from 1 to n. You have to guess which number I picked. Every time you guess wrong, I will tell you whether the number I picked is higher or lower than your guess. You call a predefined API int guess, which returns 3 possible results. -1, your guess is higher than the number I picked. Guess is lower than the number I picked. And 0, your guess is equal to the number I picked. This looks like binary search, but as an API. But I think I'm going to have to wrap it up there. I'm getting close to the call time. So, rip. I talked too long in the beginning, but it'd be like that sometimes. You still got a nice 50-ish minute session in. So I'm going to call it there.